Hello students, welcome to the interesting chemistry where you will find a feeling of classroom teaching. So if you want to enjoy classroom teaching from your study room, then you will have to watch the video of interesting chemistry. For your kind information, I have just started making video on different topics. So I have completed the language, that is the formulation of ionic compounds and their equations, balancing equations. If you watch my video, that video you will forget to mugging the equations. 80% equations you can understand by watching my video. Second one is the complete study of the IUPAC system of the nomenclature of the organic compounds. And third one is redox, oxidation and reduction reactions, oxidation number, and the balancing of the ionic equations. For today, my topic is the quantum numbers. Quantum numbers. Quantum numbers are related to the electron. As you know, electron revolves around the nucleus in an atom. So this electron have a varieties of properties or characteristics that are the energy in the energy. Or second one may be that is the location or the size of the electron, or the shape of the electron cloud. In this way, to define these all properties or the characteristic of the electron, we need to four numbers. That four numbers are called a quantum number. So, to concise the definition, I am telling you again, to define the energy and the location of an electron, we need four numbers. These four numbers are called a quantum number. So there are four quantum numbers. One is the principal quantum number, azimuthal quantum number. Third one is the magnetic quantum number, and fourth one is very easy, that is a spin quantum number. So I am going to tell you only two, explain you only two quantum numbers. That one is the principal quantum number, and second one is the azimuthal quantum number. So first I start the principal quantum number. So these quantum numbers also tells us the energy and the location. Location means I am going to tell you about your address which you gave in your post office, that why the postage you receive your postage at your home. So like the district, and there again district has tehsils, and tehsil there is a village and the tehsil. So you can start district, tehsil, and then village. In the same pattern, the quantum number also tells us the main energy level due to the energy, main energy level, and second one tells us the sub energy level. So first I am explaining you the principal quantum number. Principal quantum number is like a district. Principal quantum number is like a district. This is the main energy level of electron. And as you know, the electron revolves around the nucleus in an atom in different orbits. First orbit, second orbit, third orbit. So here we will name that orbits are called as cell. So the main energy level of electron is cell. You can say this is cell. And the cells are different. Now then you will write here. Here one thing I forget to tell you, to advise you, that please pause this video 42 minutes and take down my all black word into your notebook. So you will understand easily when I will explain. So please pause it. I hope that you have noted my blackboard work into your notebook. Then now I am going to explain. So I have explained the main energy level. Number 2 is this symbol. What is the symbol of the principal quantum number? Small n. Whenever you find in your book small n, it means it is the principal quantum number. So principal quantum number, so you need to know the value of the principal quantum number, the value of this n. What are the values of the n? The values of n is equal to 1, 2, 3, 4, 5 and 6, so on. This can also be noted with the K, capital K, L, M, N, O. If I say to you M cell, it means it is the third cell. If I say it is K cell means it is first cell or the first orbit. So this is the values of n. Now I am telling you this is nucleus. This is first cell, second cell, third cell, fourth and fifth, and KLM. Here the electron are revolving second, in third, in each and every cell. The electrons are revolving in first, second, in the multi-electron. In hydrogen spectrum we find there is only one electron, so we are confined up to the only first cell. But in multi-electron there may be more than one cell. So these are the name and cell of these cells. So here now again there are this electron and compare this electron. I am telling you about the energy. The energy level of the electron increases as the distance of the electron increases from the nucleus. Suppose compare the energy of electron of the first cell, K cell and O cell. I am going to compare. So the energy level, so the energy of the electron of the fifth cell is greater than the energy of the first cell, electron of the first cell. As the distance increases, the attraction of the nucleus between the electron and the nucleus will decrease, because on increasing of the distance, the attraction between the electron and the nucleus will decrease. Hence, the energy of the electron will increase. So in this way, it tells us the location. It tells us the location that this electron is far from nucleus and this electron is near to electron. This electron is greater in energy than this electron. So here distance, according to distance, tells us the level of the energy level. Again, then how will you come to know that how many electrons are there in one cell? There are so many cells, 1, 2, 3, 4, 5, 6. These are the cells, and we can calculate the number of electrons found, maximum electron found in one cell. Which one? By the formula of 2n square. So number of electrons in a cell can be calculated by the formula of 2n square, where n is the number of cells, number of orbits. So here in first cell, You can calculate in the number of electrons in first cell. Here the number of electrons in first cell is equal to 2 into 1 square. This n 1 square 2. So 1 square 2. I think that you have understood it's the 2. And in the second cell, this will be 2 into 2 square is equal to 8. And third cell, 2 into 3 square, 18. And the fourth, 2 into 4 square, 4 into 4, 16 into 2, 32. In this way, 2, 8, 18 and 32. These are the number of, respectively, the number of electrons found, maximum number of electrons found, may be found in K, L, M and O cell. K, L, M and N cells. So this, I told you the number of, in the same way, here you can calculate the energy of an electron by this formula. This whole value will calculate it as a Rydberg constant, that is 107,799. I think that is the value of the Rydberg constant. And here is n square. So n square 1, 2, here it is minus. So the n square will, by putting the value of n square, when the value of n increases, so the energy will also increases. Energy also increases. In this way, you can calculate this all around the district. But now I am telling you about the Tehsil district, because there is no existence of Tehsil without district. In the same way, there is no existence of the second quantum number without the principal quantum number, that is the azimuthal quantum number. Azimuthal quantum number is also called as the subsidiary quantum number. Subsidiary quantum number, or the sub-energy level of electron. Sub-energy level of electron. So again, the symbol of the azimuthal quantum number is L. The symbol of quantum number, azimuthal quantum number is L. Now, this L have so many values. How will you calculate the value of azimuthal quantum number over the L? It means, how will you find this number of subcells in a particular principal, particular cell, or the principal quantum number in the first cell, second cell, third cell, fourth cell, or I am telling you, in first cell there are how many how many subcells are there. In second cell, how many subcells are there. So how will you calculate? So you can calculate, this is the value, this is the formula, this is the L. L is equal to 0 to n minus 1. L is equal to 0 to n minus 1. And n is the same thing, the principal quantum number. So without the principal quantum number, you can't calculate the value of n. And from here, this value varies from 1, 2, 3, 4, 5. So the value of L will be varies with respect to the n. With respect to the n. If you want to calculate the subcell in the first cell or the first orbit, you will write n. If n is equal to 1, it means the subcell, you are going to find the number of subcell in the first cell. So L is equal to 0 to n minus 1, 1 and 1 minus 1, 0 to 0. It means it is equal to 0. It means it is equal to 0. 0 means not nil. It's an entity. It shows us that there is a one sub-cell in this first orbit or the first cell. It tells us zero. Zero tells us there is a one subcell in the first cell or in the first cell. So this zero and this zero is the notation of this zero is S. Whenever you find these are the zeros, this zero shows as S. So if I ask you what is the value of S, what is the value of L for S, you can say the value of S or L is equal to 0. And this is S. Again, when n is equal to 2, again the same formula, 0 to n minus 1, 2 minus 1, it means 0 to 1, and you will write 0 and 1. It means there are two subcells in the second orbit or in the second cell. So here this is 0. I have told you this is S. So again it is S. And this one is called P. This one. So P, the value of L for P is 1. The value again. Now you are noticing that here is S and here is S. How will you differentiate both S? So you can write it is 1S and it is 2S. It is the S subcell of the second cell or the second orbit. It is the subcell of the first cell for the first orbit. You can write here 1S, 2S. Again, now come to the 3. That L is equal to 0 to 3 minus 0 to 0, 1, 2. So again, 0 means S, 1 means P, and 2 means D. So here I am writing S, P, and D. Here, 0 S, 1 P, and D. So here again, this S will be 3S. This S will be 3S. This P will be 3P, because so it is 2P. This 2P and this is 3P, and this one is 3D. In this way, you will write 3S, 3P, and 3D. 3 tells us the principal quantum number or the number of the cell in which the cell. Suppose if a electron revolves in 3S, it means it revolves in the third orbit. And there is a subcell that is called S. So here this electron, the electron that revolves in the third orbit or the third cell, and the subcell is S. So again, I am telling when n is equal to 4, that I think that you understood 0, 1, 2, 3, 4, and here you will write here 4S, 4P, 4D, and 3. Here is 4F. I have written the values of L of different subcells as the value of L is equal to S for 0, P for 1, D for 2, and F for 3. This is very important when I will discuss you the electronic configuration. There is a rule that is N plus L, where you should know about the value of N of different subcells. So here I told you. Now I am telling you again, the energy level of these subcells, the energy of the F subcell is greater than D, D greater than P. This is the sequence of the energy level. So if a electron found in D subcell, that will be a greater in energy level with the comparing to the D, P and F. If a electron revolves in the D subcells, then the energy of that electron will be greater than P and S. So this also tells us this. As I told you in the previous class, these quantum numbers tells about define about the energy and the location. So this is the location F subcell, and the energy also defined with the, because the energy of the F subcell is greater than D, and the energy of the level, energy of the subcell D is greater than P, and so on. So it is the sequence of the energy level. Again, same here. I told you that it also that electron is in a wave function. So it is in the form of electron cloud when it revolves. When it revolves around the electron, the electron is found in the form of the electron cloud. So here the shape of the electron cloud of the S, this S is formed from the spherical, so it is S. So the spherical electron cloud, the shape of the P. Shape of the P, see this P is dumbbell shape. It is like dumbbell shape, and it is double dumbbell. So you can write here and double dumbbell is in this way. This is another topic I will tell you in different video about the shape of these clouds. So here again I am telling you this shape of the SP. The S is spherical. The shape of S is spherical, but the size of the S will increase according to the increasing the number of orbits. As the size of, suppose here you will find here is also S and here is also S. So the shape of both the SI is equal. Shape is equal. Shape is spherical. This S is spherical and this S is also spherical, but the size will increase as the distance, on the increasing of the distance, the size of the subcells will increase. So it also tells us as we go this distant from the nucleus, so the size of the cell or the main energy level increases, size of the subcell also increases. The 1s, 2s is greater than 1s, 3d is greater than 2d, 3d is greater than 2d. Did you notice I am on mistake? I think some of students didn't notice my mistake. I am saying 2D. There is no 2D. Here is only 2 cells. Here, so please be careful when you give some example. I have given the 3D is greater. The size of the 3D is greater than 2D. Am I correct? No, I am not correct, because there is no existence of 2D. So I should say the size of 4D is greater than 3D. In this way, I think I have completed this tehsil. So there are, because these are the district, this district, in the second district, this district is somewhat a large district, so this has 2 tehsil. This is again large district, this has 3 tehsils, and this district, fourth one, has 4 tehsils. In this way, the number of cells increase according to the size or according to the number of principal quantum number. So I think it's all for today. I think that you have understood what I am going to make you understand about the quantum numbers and the principal quantum numbers and the azimuthal quantum numbers. Now here, one more importance, this n tells us the number of cells. Number of cells. If the value of n is equal to 2, how many subcells are there? How many? If n is equal to 2, there are 2 subcells. N is equal to 4, there are 4 subcells. So n also tells us the number of cells found in that particular principal quantum number. So it's all 2n squared tells us the number of electrons, n tells us the number of cells. So when the values are dependent on the n, so the azimuthal quantum number also depends on the principal quantum number. When I will come to the third, in my next video, third quantum number, that is the magnetic quantum, that is also dependent on both the sub-level and the main level. So again, this is all for today's video. Please like it and share it. And I also advise you to share, to tell about this video to your friends. That's why they can also take some benefit from these my videos. My videos are like a classroom teaching. I have no formalities. So again, that's all for today. Thank you very much.